Good morning, everyone. Welcome to another one of my little webinars. Thank you for putting up with me. I'll try to make this one enjoyable as usual. So for those of you who can't attend the whole session, or if you want to look afterwards, of course, we'll share a recording afterwards. Feel free to ask questions. I will try and tackle those questions depending on where I can cope with the questions coming in, or I'll just tackle them at the end of the Q&A session. Yeah. To keep you excited, spoiler alert, there will actually be two pricing announcements or promotions or commercial announcements during this webinar. So yeah, stay tuned. I am going to stop my camera and I'm going to share my presentation over there. Okay. Is my screen coming in okay? Can someone just give me a heads up?
Yes.
Okay. Thank you. So yeah, today's session will be about the Trimble GNSS legacy. So it's actually 4 years now that Trimble's been developing GNSS kit. We'll get to that in a second. First, yeah, last year we did a little inquiry around our customers, for which then we derived what we call our brand promise, which is trust. I'm not going to read the slides, but basically, in all of our interactions with our customers, we try to be open and honest. If we say that we're going to do something, we bloody well do it. We ask a lot of questions back and forth to understand what the customer wants and needs, and be supportive in your requests so that we can grow our business together moving forward. And we make our best efforts to reply to you in a timely manner. Little agenda, 4 years of legacy, our positioning services, the ProPoint technology, as in the Y of Trimble GNSS performance and repeatability. And last but not least, I have a couple of slides on controllers and our software. But yeah, 40 years. So this is what the Trimble Geospatial product timeline looks like for the last 4 decades. It's actually 40 years in 2024 since Trimble released the first commercially available RDK receiver back in 1994. It was 5 at the time. And you can see in the last 5 years, Trimble is continuously developing and releasing new hardware to the market at the rate of almost literally one a year in the last 5 years, and that also accompanies field controllers and other bits not GNSS related. So yeah, it's quite a long history of development and knowledge and experience in this space. I thought it would be a good idea, because sometimes I get a lot of customers just accepting the button pressing operation of basically every bit of surveying technology, not really sometimes understanding what's going on in the background. So apologies if some of you in the call are well versed with this, with the theory behind it. For those of you who are not, allow me 60 seconds to go over this. What is GNSS? GNSS, yeah, it's what's called global. It's an acronym for Global Navigation Satellite System, which effectively comprises of 4 independent constellations managed by different countries, or in the case of Galileo, a union of countries. Why does it matter? Well, it matters because when I first started this 25 years ago, we only had GPS to work with. They had like 21 satellites at the time. At any given point during the day, I would have access to 5, 6, maybe 7 satellites with any luck. It was difficult to measure points. in even easy conditions, what I consider to be today easy conditions. But we need a lot of satellites to measure more points, so that we can triangulate our position a bit better, which is why now we have basically 4 times the amount of satellites that we had 20 years ago. So at any given point in time, you'll have 20 plus satellites to work from across different constellations. How does the positioning process work? So for you to figure out your position at any point in the planet with what we call in the industry of an autonomous precision, i.e. to a degree of accuracy anywhere between 3 to 10 meters. We get some signals from the sky, but I like to explain this in terrestrial station terms, because a lot of people are more familiar with that. So it's like a terrestrial station resection, really. I used to call this a trilateration, if you're aware. So I'm rephrasing it. So it's like a terrestrial station resection, but where the baselines are actually in the tens of the thousands of kilometers to your satellites. And the control points, i.e. the satellites, are moving at thousands of miles per hour. And it's still very much impressive that with all of this, we're able to get, with no additional help, an autonomous position just with an error of a few meters anywhere on the planet. If we want better, essentially what we have to do is pick a known point, fixed point in space, which we will call a base. That base will have an error to the autonomous positions, and then we'll differentiate that error to the rover, which we call our corrections. I'm probably oversimplifying this. Those corrections, in the case of a base and rover system, which we call traditionally RTK, are then transmitted by radio to a rover to enable you to get to centimeter level accuracy. Trimble VRS is a positioning process concept, which is based off RTCM, which is a worldwide standard, on which you get those corrections. I'm not going to get into the mathematics about it. By the way, spoiler alert, we're planning to do another webinar just purely focusing on the mathematics and the whys of VRS and other bits and bobs in a couple of months directly with Trimble, so we can drill in a bit more on these specs, on the technicalities of this all in a couple of months. But for now, RTK on a real-time network, you get your corrections from a network by mobile internet signal. And VRS is a technology that Trimble has acquired and has been continuously developing since 1998. So it has almost like 30 years of development into it. And there's another technology where you're not getting your corrections from a radio base station or internet. You're getting them directly from a geostationary satellite, which in the industry it's called precise point positioning is a technology. The service is called for Trimble is called RTX, and the corrections are called XFIL. So it's all a bit, never mind the acronyms, but essentially we have 3 ways of getting corrections, either by radio, by my mobile internet on a network, or by satellite corrections on a global network, which is the main difference between a VRS, which is local, and precise point positioning, RTX, which is global. So how does Trimble VRS now works? There's a little video.
Virtual Reference Station Technology, or VRS, pioneered by Trimble over 2 decades ago, remains a proven, cost-effective choice for any real-time GNSS survey application. Trimble VRS Now Correction Service provides surveyors with the power to just connect, correct, and measure, all with the peace of mind of around-the-clock network monitoring, always delivering the reliability your work demands. With continuously evolving global constellation systems, we have more satellites available to use for your real-time correction stream than ever before. Using the newest constellations gives you increased reliability and more robust service. With Trimble VRS Now Correction Service, buildings, trees, even hills are less of a challenge, resulting in more robust, accurate data and less vertical error. Trimble VRS Now is a network RTK service that eliminates the need to set up your own base station, simplifying job site logistics. eliminating capital expenses. You get the job done quickly, the first time and every time. Let Trimble VRS now harness the power of satellites to give you the real-time precision you need. Less setup, more time measuring, and the around-the-clock peace of mind that Trimble is monitoring the network so you have real-time data always. Accurate, dependable, easy. That is Trimble VRS Now.
VRS, for which you can get a free trial from this system, whether you are a Trimble user or not. Actually, just reach out and we'll sort you guys out. Yeah, we've all been there. So whenever we lose our corrections in the field, here it's because of an obstruction. But realistically, in UK, what happens is mobile internet usually goes down. So, and you go from an accuracy of 10, 20 mil down to meters, basically, until such a point where your internet goes back up. So, if you have access to this precise positioning service, which we call Xfill in the Trimble gear, what happens is the software on the controllers will automatically switch to this correction service, and there's actually two flavors in which it will happen. I will circle back to that, but it was developed so that you have positioning insurance against drop downs in your mobile internet. So it will carry on with the same level of accuracy as VRS up to a point, and then it will degrade a bit, but there's a limit to how it will degrade, but it will still maintain what we call what I call an RTK level of correction. So the Xfill correction service, as I said, comes in two separate flavors. One, which is 5 minutes. So whenever your either base station correction by radio or VRS connection by mobile internet drops, it will automatically flip to Xfill up to 5 minutes. And you'll see that happening on screen. And then when the correction goes down entirely, you also see that it will drop. The other version of that is that it's always on. So it doesn't matter how long you go without internet, this system will be continuously on. Why is that important? Well, basically because it avoids downtime. Yeah, it gives you that extra time to measure a few additional points where you don't have to bring out the total station, or if you do need to bring out the total station, it gives you enough time to measure those resection points. We have been speaking with more and more customers about this feature, and we've learned actually two things. A lot of our customers were already using this service, the Xfill Limited, without knowing. But when we brought it to their attention, they're saying, actually, this is saving, now that you mention it, this is great because it's saving us a lot of time, because every time we have to take a total station out, that's like half an hour of our day that goes away. Whereas using this technology, we don't have to spend that time getting total station out. The good news is, and there's the first offer of the webinar, for our current GNSS portfolio, so the 12Is, the 780, and the 580, all of them have this Xfill Limited as standard for up to 5 minutes. So all of your Trimble gear will automatically switch to the satellite correction if the internet goes down up to 5 minutes, and it's a permanent feature. Yeah, it will always work on Trimble gear. You don't have to pay extra. It's included as part of the standard offer. What we have as well for our VRS users, so if for anyone that is using our VRS subscription, anyone that wants to have a new subscription or renewals, you can have, at no extra cost, the unlimited version of that. Will not be restricted by the 5 minutes limitation, if that makes sense. And even if you want to have just a trial of this independently to what we have here, give us a shout. We'll sort it out. It will. I will reiterate, this will only work with Trimble gear, this Xfill service. Expected accuracies. I'm not going to read the slide. You guys can take a screenshot or watch a recording afterwards. but we always like to check what we get against what's on the data sheet. We know now for experience that VRS now is to this level of accuracy, whereas exfil, so the time limited stuff, is as accurate in terms of horizontal values. Vertical is still not quite as good as VRS now or radio, but if I think in terms of the product development, this used to be like 10 years ago, used to be 10, 15 centimeters horizontal, 30 centimeters vertical, the best that we can get. Like any other networks, this service, positioning service, is based off a worldwide network of receivers. The more receivers Trimble installs over time, the lower these numbers will be, and this is what we've been seeing across the planet. To say that if you do have that RTX service in your systems, you can basically work anywhere in the planet where you have coverage through one of those satellites broadcasting corrections. Yes, there is a way to get to higher latitudes using a different way of connecting to RTX. I'm not going to jump into that now. If you want me to explain it, I'll happily leave the 101 with you. But it's a worldwide service that has over 20 years of development into it, and it's getting better and better over time. This might be familiar for you Trimble users. So R12i controller, whenever the controller actually flips to between RTK on VRS and exfil, it changes information that you see on screen. This is a simulation. So if this video was taken from a real controller, whereas if you click the world icon and hit the pause button, that effectively cuts off your internet connection. And if you give it a few seconds, you'll see that it flips to RTK exfil. And you can see that it's still maintaining the same level of accuracy. And as I said, as standard, all Trimble gear on the latest portfolio will keep this connection going up to 5 minutes, up until which point it will give up, or if you get your internet back, it will resume, which is what we'll do here on the video as well. So we're going to get the internet connection back up, and you'll see that the icon will change back to the world with the green tick again. Give it a few seconds. I will speak slower to buy myself time for the video to catch up with what I'm trying to explain. Go on. And I will apologize again to the class. I'm not as funny as I think I am. Me and my jokes. You have the satellites. And a few more seconds. I'm going to push this forward. 3, 2, 1. And RTK plus MU was the last bit. Okay. So world with the green tick. Yeah, so the software in the field will inform you on that. We never do anything. You know, I'm old enough to check everything, so I don't really trust implicitly what the controller says, and I know that you guys don't either. So we always check whether what the controller says is actually based on truth or not in reality. So this was actually recently. I've asked one of our specialists, Phil McCartan, to do a couple of screenshots from this controller on the fly. You know, nothing really professional here in terms of picture taking, but what he did was he resected the turtle station from a few GNSS points. He measured a couple of points with the turtle station, and then he flipped to this precise positioning service, RTX, and staked out that turtle station measured point. And you can see that the vertical accuracy is 30 mil, but then it's saying that the real vertical cut is 43, which kind of goes in line with that 5 centimeter absolute accuracy that was stated in the service. But the horizontal accuracy is pretty much bang on where it should be. So I'm happy with that. And he did the same, now measured against a VRS measured point without the IMU, without the tilt function on. So that is the simplest way of comparing. And yeah, and again, this is very acceptable to me. Hopefully that makes sense. If there are any questions or whatnot, again, just throw them in the chat window. Yeah, Trimble test these technologies over and over again. That's a dispersion of points, of hundreds of points measured between both systems, so VRS and exfil, just to prove that the horizontal accuracy is essentially the same up till that 10 minutes mark. You guys will be fine using the service. Vertical will degrade a bit more after those 5 minutes. Technology changes the way that we work. Part 1. I'm going somewhere with this. So it used to be the case, and I'm hoping most of us are old enough to remember that actually we used to carry all sorts of different devices with us for a number of different reasons: entertainment, communication, timekeeping, paying things, taking pictures. Whereas through miniaturization and increasing processing capability and improvements in technology, we're all combining all of those devices into a single one called the smartphone, which gets better and better over time. This changed the way that we work, actually changed the ways that we live and behave socially as well. You might remember from my previous webinar about laser scanning. This is what a Trimble laser scanner used to look like 20 years ago. Heavy, convoluted, targets, cables, batteries, all sorts of things that you have to bring with you to site. But again, through miniaturization and increasing in processing capabilities, everything is much simpler and faster now, and everything contained in a really high powerful tablet that you bring with you to site. So this changed the way that people work and enable a lot more people to access the laser scanning technology. So Trimble ProPoint is our trademark technology on our GNSS kit, which essentially did the same. So I remember when I started working, Trimble had an R8 first generation. There was only 24 channels there. It was only tracking the American constellation, and we were up to the first generation of the processor on board, the Trimble Maxwell chip. Whereas now with the R12i, we have two 7th generation Maxwell chips, which enables the R12i to have dual core processing, which, like a computer, enables the system to compute mathematics much faster and much more reliably. And we're able to track all 4 constellations as a standard on that unit. What does it mean? Well, it means that before, actually not that long ago, in those terms, whenever we got to a situation like this, as a surveyor, you have to be like sad and depressed and, oh God, I can't measure that point. What am I going to do? Well, we know what we will do. We will figure out a way with a tool station or what have you. But it was always kind of disheartening. Whereas now, through the improvements of technology and on how Trimble is able to filter out signals and compute best mathematics and increasing in processing, which is the hardware improvements in the actual unit itself, we're able to sort those difficult measurements on the canopy or buildings a lot better. And including all of that technology and combining the sensor fusion within the R12i, with the ProPoint, with the exfil, with the tilting technology, we're able to do now stuff like this, where you can get underneath a canopy and get like real proper accuracies underneath it. It's not just about, and for me, it's not just about the ability to measure things on the canopy, is that if you take the system out of that canopy and go back again and take that point, you're going to get the same result. Repeatability is paramount for Trimble. Repeatability, reliability, these are the cornerstones, foundations upon which Trimble GNSS has been built over the course of the last 4 years, basically making the impossible possible. So you can get out of sight now, laughing with a smile on your face. I have a feeling that this slide will become a meme at some point. As I said, yeah, testing is what makes the customers trust Trimble GNSS. So this is just a few slides to explain that before the ProPoint technology was officially released to the market, this is only a very small fraction of the tests that Trimble did with the system in different sorts of conditions. Canopy, partial. Again, I'm going to skim through over these slides just to say, yeah, mimic different situations, different conditions to test other things other than being able to measure point underneath under canopy or close to buildings. But this is the results of having a ProPoint enabled receiver versus one that doesn't have ProPoint. In this case, I'm comparing a Trimble unit with a previous generation Trimble unit. And you can see that, for example, on the medium canopy, there was like 30 shots here, and the accuracy on the medium and repeatability on the medium canopy has been increased over by a factor almost of 8, actually, even though the scale doesn't really help. You're looking at 70 mil up to 93. This will be similar, potentially similar to even other receivers from other brands. So this is the value in ProPoint, making sure your topo surveys or control points measured are correct. If you want to have a look, I have another 20 different slides just with the rest of the results from those tests, which I'll happily share if you reach out to me afterwards. So all of our current portfolio is ProPoint enabled. All of them have that technology. They will all work essentially the same. For the discerning eye, you'll notice that the R12i will be a bit more accurate and it will be a bit faster because of the dual processor, the dual Maxwell chip that he has on board. The other ones have just one chip. I say just the one. They're still pretty great. I know we're talking about improvements of 2, 3, 4 mil every now and then that you'll notice on your measurements. So yeah, this is the main part of the portfolio. So the R12i is what we call our premium solution, is the all-in, all bells and whistles. So there's no options on the R12i. You'll get it with standard, with all constellations, base and rover being ready to broadcast, the tilting technology all ready to go. Whereas the other ones are, this one is scalable, and the 780 is a scalable unit. I will tell you about the options in a second. And the 580 is what I call the best value for the one with the best return on investment, which is the one, if you invest in it, you're able to get your return a lot faster. And it's the one that we, as Corec, we also sell for both the survey and GIS market, because it's able to cope with different controllers for survey and for GIS, and with different softwares as well, things like TerraFlex or Esri or our own K-Matic software on controllers. So comparison table, just on the main features on what we have. So as I said, the R12i is all included, no extra options, bar the NEA, if someone is paying attention. And it does have the, has proven otherwise. I don't think I will, but it has the most accurate tilt function on the market. So that's 5 millimeters of uncertainty on tilt measurements. On the 580, the tilt is an option, the multi-constellation is an option, and enabling the radio to transmit is an option. And the 580 has all the constellations enabled as standard, and there's no additional options, and it doesn't tilt. If you remember this, yes, people were really serious about software should make their own hardware, and Trimble does so for the GNSS as well and for the controllers. So, and why? And it's, at the risk of repeating myself, yeah, it's the same reason why Trimble makes their own hardware for laser scanners, is to make sure that the communications work properly. The Wi-Fi works properly, the Bluetooth works properly, the software works properly on the controller, which Trimble also develops to avoid things like data corruption and downtime, waiting for the Bluetooth connection to kick in or to resume, or when you're trying to switch between Trimble Station and GNSS, it takes time. Sometimes it doesn't work. You have to restart things. Yeah, Trimble doesn't do any of that for almost 20 years. I cannot remember the last time I had a Bluetooth problem with any Trimble kit. It just works, which is probably the main thing that any Trimble GNSS user anywhere on the planet will comment when asked upon what do they think about Trimble GNSS. That's always without fail the first tagline. Speaking of controllers, there's a huge legacy of field controllers in Trimble. Trimble developed and supported field controllers. This is already out of date. This picture is already out of date 3 years, because after this there was already a new version of the TSC7 that was released in 2023. Looks the same, but it has a different processor, more memory, more powerful. So yeah, just keep on updating all of these controllers, and this is just the ones that have a keyboard on them. I'm not counting here the tablets and the ones that don't have a keyboard. Continuous development. Why? So this is the latest version of the controllers that we sell here for Trimble stations or GNSS. Why is Trimble continuously updating their controllers? Well, one, because it's just the way to give back to the market, something that it's up to date. And secondly, so that when you invest in one of these controllers, they will last you for the whole lifetime of the product without you feeling that you're going slow, that things are getting slow over time, or you feel that it's getting outdated over time. To say that the oldest quote unquote controller that we have at the moment is only two and a half years old, but it was spec'd to last. So if I go back to this particular previous slide, fortunately or unfortunately for us, because it makes it difficult to trade in, these two controllers, so 25 and 2011, these ones lasted in the hands of the user easily like a decade, easily, before they felt the need of changing upwards to support things, like cloud connectivity and point clouds on the controllers and what have you. But yeah, spec to last. Don't limit yourselves to controllers which have not been updated in the last 5, 6, 7, 8, 9, 10 years. Go with something that works, Android-based. There's nothing else like that anywhere on the planet for controller supporting Android. Also, if you're in the construction space, apologies, I was thirsty. You need to think about what tools you need to bring with you to achieve your tasks. So Trimble Access has all of those features included as part of the standard package, where other softwares you might have to pay extra at a cost. And again, Trimble has this almost 40 years old mentality of let's just give the people what they need to work. What they need to work, because that releases pressure on the customer, that enables the customer to be more productive. You don't have to think whether I'll be able to achieve a task or not, because that's already included in the software. So bring value to the customer by giving them what they need. And also, as part of our correct remit, we have to work locally with different third-party software providers to make sure that the workflows work from the field to the office, in case you're not using our office software. And the fact is, in UK, most of the companies are using a third-party software anyways. So we just need to make sure that we are engaging with these providers, and they happily speak with us to make sure things work. A good example of that is recently, Phil Langridge from Enforce. They've included a feature in their software which enables them to seamlessly connect to our cloud-based data transfer and collaboration system, Trimble Connect. So what that means is you can do a traverse with your Trimble Tool Station on site. You can upload the data seamlessly over the cloud to Enforce. An operator in Enforce can process your traverse data, get your adjusted reduced coordinates done, and then upload that file back to to the user in the field. You get a little notification. Please download your driver's data, and off you go. No muss, no fuss. Nice and seamless workflows. I know that Mr. Shane McLaughlin is also working on similar workflows, and yeah, we have other people connecting with the other manufacturers as well. If there's anything on your side that you think you should need or a different software that you could need help with in terms of optimizing some workflows, give us a shout, drop us a line. We will get it sorted. For me, this is the most important for me slide about Trimble. It's the reliability of it all, because it just works. So when I say that Trimble is doing laser scan, GNSS for 40 years, it's practicing and making it better. Practice does not make perfect. Only perfect practice makes perfect. How many times you see someone adopting a process, and every year they keep on doing the same thing over and over again, and it's not really improving. So it's not about practicing, it's about making the right things. And Trimble has been practicing, perfectly practicing the craftsmanship of GNSS surveying for over 4 decades now, which is pretty unique in the market. No one else has this much experience here. It just works as the #1 statement across all Trimble GNSS users, guaranteed for a fact. It's like magic is the second one. Arguably, it might be me saying it, this particular one, but the just works one is certainly for a fact the #1 statement. Reliability for me, it's what enables productivity. Why? Because if things are reliable, if you turn a GNSS kit on, it will do the job that it needs to do all day long without fail up until the time that you have enough. There's no downtime. And time is the one asset that we cannot buy more of. So every time we lose time because of GNSS issues, we are losing money in our business. We're losing money, increased frustration, and this is what Trimble GNSS avoids and has been avoiding for most of our lifetimes. So there's a lot to be said for having a single source of supplier for the GNSS needs. Trimble is one of the unique brands that has all of this included in the same chain. So they develop their own hardware. They develop their own multipass mitigation technology, which enables better and more accurate measurements, GNSS measurements. Clear skies, difficult conditions, continuous development over the last 4 years, to which that technology is currently named ProPoint. Their own positioning services, either by a VRS correction or precise point positioning by a satellite. Again, 2 technologies with 20, 30 years of development into it. There's no one else like it. Receivers that are able to measure tilted. It's not just enough to have the hardware and the GNSS. These things also need an inertial measurement unit, aka IMU. Trimble develops their own IMUs as well through a company called Planix, again for almost 30 years now. So it's about understanding and knowing how things work together and how it benefits the customer. Our own controllers, again, continuous development on state-of-the-art controllers that don't feel sluggish or out of date. Trimble Access. So Trimble Access, the first release was back in 2007, I want to say. So again, it has good, solid, almost 20 years of continuous development into it. This gives to the customer not only the assurance that the software is really, really stable, essentially never crashes. It's reliable, it just works, and it gives a good feature set to be able to cope with the vast majority of any topo survey or engineering construction tasks out there. And locally, obviously, we can support all of this through Corec with local service, training, and technical support, all under the same umbrella, which means that if any of these components or as any issues in any of this, you have one point of contact to call. And we do our very best to be as responsive and as professional as possible. Whereas if it's a manufacturer that is getting a controller from a place, a software from a different place, a crashing service from a different place, and something goes down, who are you going to call? I've been here before, and what happens is the customer then ends up calling 2 or 3 people and then waits for answers and then gets frustrated. Maybe save a bit of time buying a different product, but then challenges with support suck all of that time away, and you're losing money at the end of the day. So always test. All of this technology, you can tap into this technology starting from, and this is the second commercial statement of the day. Before I get into that, actually, I'll leave the numbers there for you guys to see, or take screenshots. It's fine. Always test your GNSS before investing. It's not enough to be able to measure a point underneath canopy. It needs to be repeatable. We usually do that. We encourage people to challenge us, to measure our points against total station measure points, to measure against your own kit. Repeatability, always test before investing. The last thing we want to do is we would like to hear is for you guys to invest in a system and then it doesn't provide the results that you are expecting because it was a bit cheaper. This is not how we roll. We welcome that challenge. And I did say that I was going to bit the numbers a bit. Yeah, so we have a little promotion going on. You can access the 580, which is this gray one, starting from 11,000 as a capital investment, or 462 a month based off of final simulation over 3 years. Yes, I know you know how to read as well on the slide, but I just felt it would be good for me to do so as too. Lastly, I do have the tendency to do these presentations rather fast, so I'm not sure if there are any questions on the chat. Giacomo, is Trimble RTX the same as RTX used in agricultural sector? It's the same technology, although the geospatial version of RTX goes down to the centimeter level. In agricultural sector, there are different streams that are of lower accuracy, also at a lower cost. The tractor doesn't need centimeter level accuracy, so there's something else. As a geodesy question, what are the advantages and disadvantages of using UTM coordinates in GPS GNSS positioning? I don't see any disadvantage. It basically depends on what you're doing and where you are in the world. So Trimble controllers, they have a standard, all of the UTM projections for all of the world. You can choose that, or if you have a local coordinate system, you can choose one of those as well. You can even change it on the fly if you understand the transformation that's going on. There's no real advantage or disadvantage. It just depends on what the customer wants their coordinates to be projected to. Any more questions from the class? I'm going to give this a bit of time. But while you're thinking that, I think I'm going to do a little recap here. Yeah, it's the whole reason or rationale to do this a little webinar is again to refresh the market on what it is GNSS, where does accuracy come from, what makes Trimble GNSS repeatable and accurate, and most importantly, reliable. And again, to encourage users before investing, check, test, retest, check the accuracy of your measurements against something else. because we are hearing more and more stories of customers buying different, let's say, different products from other manufacturers, and the accuracy is not quite as they said it was. Lunch. Trimble Catalyst, Constellations, all of them. All of them, Mike. Let me see if there is one. Sorry, I'm going to explain this better for the rest of the class. Mike Shamley is asking about Constellation supported by a different service that we have, which is called Trimble Catalyst. That's supported for the A2 antenna. It supports all constellations. And what ways can you download Trimble controllers? No, Stephen, not sure if I understand your question. Can you rephrase that for me, please? How do you mean? What ways you can download data from Trimble controllers? Okay, depending on Trimble controller, a cable USB, a standard USB-C cable connection is always available, or you can use a Bluetooth link to your PC, or you can upload data to Trimble Connect, which is included in all of the controllers, anyways. Even the basic version, which is free, is always available to you, so you can just sync up data upwards and downwards between the field and the office through a free application, like we do with Dropbox or Google Drive or something like that. It's actually quite seamless, and it's a risk mitigation factor as well, in case someone nicks your controller or someone drops your controller. There's another question. With advances in GNSS technology, will the use of local base station become superfluous? We don't personally. That's my personal view on it, because that's really realistically all that I can offer. I don't know. I don't know. It depends. So I just had a question this morning on from one of our sales reps, asking if using a base station by your radio would be better than using a VRS connection. Or would be better and more accurate. From experience, we know that's going to be a bit more accurate because a radio connection is faster than a mobile internet one. But it depends on the customer. If you're looking outside of the UK, there's still a lot of places in the world that don't have a VRS connection, that don't have a VRS network, that don't have mobile internet available. And where potentially the precise positioning service just isn't accurate enough for the application. Therefore, you need a base station and by your radio to use. Hopefully that answers your question. What does the product work quite compatibly with AdTTolo TopoCAD? I'm not familiar with this product, I'm afraid. Ping me an email or reach out to me on LinkedIn. We can take that conversation on the next step. So for me to investigate what this product is. Let me see, is there any more for any more? As I said, commercially, yeah, there's two. So for that RTX Unlimited thing, just give us a shout. We can enable that on your VRS renewals or subscriptions. And any other kit, we can quote for. If you have any kit that you would like for us to trade back in, we can put out a quote on that as well. Not a problem. And Mike has another question. What angle does tilt work to? So there's no physical limitation on the angle that the tilt works to. Trimble states in their data sheets, and I actually agree with that, that to maintain the accuracy stated on the data sheet for a tilt-enabled receiver, the max tilt that they can assure, I think it's 60 degrees. You can tilt beyond that. I've done the test and checked the measurements against the throw station way beyond 60 degrees. Actually, I tilted it beyond 180, as in totally inverted the pole. It's doable, but again, check what you're comfortable with. Check what you're comfortable with. It's how accurate you should be with taking those measurements, and actually how accurate you need to be. Realistically, there's no limit other than having visibility to the sky, but Trimble only guarantees the accuracy to a certain angle on the data sheets, which I think is the right thing to state. Regarding the tilt conversation, do you know of anyone using a longer staff, 5 or 10 meters? That's a good question. I don't know personally. No. I don't know personally anyone using a longer staff, but that's an interesting question. It will still work. Can I predict any limitations? No, as long as you keep the angles. As long as you keep the angle of the tilt measurement within the, I'll say, the acknowledged expected accuracy from Trimble, you'll be fine. You'll be fine. I remember I've used a bigger pole, like 10 meters, in the past, and the biggest challenge that I had at the time was actually keeping it straight before the tilt technology, because those things can get a bit heavy to use, and keep it heavy, and therefore keeping them still to make a measurement. Having a receiver on top of the pole makes difficult equilibrium, if you know what I mean. But that's realistically the only experience limitations that I got in the past on that. Good question. I will watch your space. Okay. Is there any more for any more? I can see that people now are starting to move off to lunch, and I think I'll probably do the same. So if there are any more for now, you know where to find us. Give us a shout if you want to provide some feedback, questions, quotes, comments, questions, insults, by all means. But thank you so much for your time this morning. Thank you so much for listening to me and my terrible, awful jokes. Hopefully you've learned something, and there was a bit of insight and value in there for you as well. So thank you all. Hope you have a great day.